I wanted to do one other related rates example, and I'm going to do two different related rates on this example. So this is a fairly classic example where you have a ladder leaning against a wall. It is a 15-foot long ladder, and it is sliding down. It is sliding down at 1 foot per second. And a 15-foot ladder sliding down at 1 foot per second, what we want to know is how fast is the foot sliding away from the wall, which would be the rate of change of x. And in a separate question, we're going to look at the angle here. But I'm not going to do that first. I'll just do the x first. We know that at any given time, the ladder forms a right angle with the wall. So we know that x squared plus y squared always has to equal 15 squared. If I think of x and y as functions of time, then the derivative is 2x, because that's the outside function, times the derivative dx dt, because that's the inside function, plus 2y dy dt. And the derivative of 15 squared is nothing. It is not 215 times d15 dt, although you could write that because d15 dt is 0. So now at this point, I can solve for dx dt by subtracting 2y dy dt and then dividing by 2x, like that. So 2 over 2 cancels out. To get a precise answer here, I need to plug in an x and a y value. So let's just say that we are doing this at the point where x is equal to 9. If I use my Pythagorean theorem, 9 squared plus y squared equals 15 squared, you'll find that y is equal to 12. 9, 12, and 15 make a right triangle. If I plug in those points, then I have negative times y, which is 12, times negative 1, which would be dy dt is negative 1 because the thing is sliding down. And then x is 9. So I plug that in there. The reason dy dt is negative is because it's going down. So we get 12 over 9 because the two negatives cancel out. 12 over 9, or 1 1/3 feet per second. If instead I wanted to focus on the angle here, I could set up, say, tangent of my angle is y over x. And if I wanted to do the derivative of that, the derivative of tangent is secant squared theta times d theta dt. And then over here, I have a quotient rule. Derivative of the top times the bottom minus top times derivative of the bottom over bottom squared. At the given moment, where x is 9 and y is 12, I can calculate secant because secant is 1 over cosine. So cosine of theta is adjacent over hypotenuse, 9 over 15. So my secant squared is 15 over 9 squared d theta dt. Oh, I'm sorry. I made a mistake on my derivative here. I wrote dy dx because I was thinking about implicit differentiation. I meant dy dt. And I wrote 1 because I was thinking of the letter x as just an independent variable. But I should write dx dt. So now that'll work out. So dy dt is negative 1. X is 9. Y is 12. Dx dt, we just figured out, is 12 over 9. And then x is 9, so we have 9 squared on the bottom there. Okay, after you go through all that work, you can solve for d theta dt, and that's just going to be let's see, negative 9 minus 12 times 12 is 144 over 9, and then divided by 15 squared. So whatever that ends up being is the rate of change of your angle. You can see it's negative because that angle is getting smaller as the ladder slides down. All right, thanks for watching. I hope that helped. Please ask questions.